Here we go. We're on to question 8, second long question. This is a financial maths question. Now, you might remember in last year's Leaving Cert 2023, the easiest long question was financial maths. Now, unfortunately, a lot of students and their teachers had maybe steered away from financial maths because it hadn't come up in a long time, and it particularly hadn't come up as a long question worth 50 marks in an awful long time, almost a decade. So with that in mind, a lot of people hadn't kind of focused as much attention on it. But you'll notice in a lot of the pre-exams by all the pre-companies, the financial maths is nearly always a long question. So it's one I would suggest to students maybe, not to avoid. You will see in this question that the language is dense. It's tricky to read through it and figure out exactly what's to be done. However, the actual mathematical skills aren't so bad. So let me read through. An ordinary annuity is a series of equal payments made at the end of consecutive periods over a fixed length of time. While the payments in an ordinary annuity can be made as frequently as every week, in practice, they're generally made quarterly, monthly, quarterly, semi-annually, or annually. So in an annuity, maybe like a pension, you might be getting your pension every month, Show that the future value of €1 invested at the end of each month, so at the end of each month or every month, for a period of n months at a monthly interest rate of I% can be written as this formula here. So, okay, again, you need to have a kind of think about that, because you might be thinking, you could be kind of, considering different possibilities as to how to do it. Okay. What I would remind you of is, of course, if we're talking about putting €1 into a bank or a savings product, we're talking about compound interest formula. F is equal to P times 1 plus I to the power of T. Okay. So basically what we're going to say here is for a period of n months, and just to keep it simple, because I will explain this part, because it's absolutely vital you understand the context of this part of the question to be able to understand everything else. So let's just say in our case, I'm just going to say e.g. 12 months, right? Just for the purpose of the example. So what I'm saying is this, right? That if we started off in January, okay, and finished up in December, okay, so I'm going to say this was my December payment of €1. Okay. So I put that €1 into the bank, and it's at the end of December, as they say. And because it's just literally put into the bank on the 31st of December, and that's the end of this investment, it doesn't earn any interest. So it's in there for that 1 month. Okay. Not even 1 month, just that one, theoretically it's in there for 0 seconds. It's like you put it in like the last millisecond before midnight, and then it's over. The payment for November goes in at the end of November. So you lodge it on the 30th of November. It's in the bank for 1 month. So there's one compounding period. Okay. There's one compounding period. So it's in there for that amount, that length. Okay. We actually don't need that little one there. It's a typo. And then we'll say the October payment is in there for 2 months. And if I go all the way back, the January payment is in there, and it'd be for 11 months. Okay. So in my case here, it'd be like 12 minus 1. And why is the January payment in there for 11 months? Because it's in on the 31st of January. So it doesn't earn any interest in January. But the 11 other months, there is the compound interest applied to it. Okay. So that's just by way of an example. Now, once we go from here, and on the very next line, we're going from financial maths to sequences and series. Okay. Because it is a geometric series we're dealing with there, where in this case, we're going to be using our SN formula. In our first case, like term 1 is equal to A, right? My first term is 1. Term 2 is going to be 1 times 1 plus I. So therefore, if I divide term 2, so as we know, R is equal to term 2 divided by term 1. we're going to end up with or I plus 1 over 1, which is just going to be I plus 1. So now we have A, we have I, and N is just going to be N because it's N periods. So we fill this in. All of a sudden then we're starting to get close to where we want to be. We'll just have a look at it and we can see it. If we drop the bracket here, what are we going to have? Well, those ones are going to cancel out. Just be careful with your minus. You're going to be, the minus 1 is going to be multiplied through the bracket. So we're going to end up with a minus I underneath. And then we can say, well, let's multiply top and bottom by minus 1. And hey presto, we get the answer that we want. Okay, so we have our answer and we have our marks there of 10 marks. So for the student who's familiar with this stuff, who can read the question, understand the words, you can see that that's not rocket science to do that, right? But a lot of students might look at it and say, I'm moving on, and some people might have thought it was the formal proof that's associated with financial maths for the amortization formula. But of course it isn't when you look at it. Okay, so that's part A done. Let's move on to part B. So there's an intro to this as well. And the language here, again, wouldn't help necessarily, but this is the kind of language that can get used in the Leaving Cert. The future value interest factors for an ordinary €1 annuity, for an ordinary annuity of €1, is shown in the table below. I is the interest rate per payment period. As a decimal, corrected 3 decimal places, and N is the number of payment periods. So, okay, I is your interest rate, and N is your payment period. So it doesn't associate with like a year or anything like that. It could be 10, 20, 30, 40, and the various interest rates here, going from, I suppose, low to kind of high, So low and getting higher anyway. If you were earning interest, you'd like to get this one over here. Actually, I've only, my attention is drawn there to, like, if the compound interest rate is, if the interest rate is 0.240, which is 24%, your €1 goes crazy after a while. You're up to 22,728 after 40 compounding periods. So that's what you want, compared to it just amounting to €41. But that's a different day's work. Okay, verify the future value of €1 invested at the end of every month for a period of 40 months at a monthly interest rate of 2% is equal to €60 and 60.40198. Correct to 5 decimal places. Okay, now, if I was a betting man, I would bet that people inside the exam were confused at that point. They weren't quite sure what to do. However, it is following on from the previous part. We have the formula given to us in the previous part, okay? And it says, and we did have it, so we could just use it. And what we're saying is, in this case, you see, we're putting in the €1 because that's what this formula is associated with. €1 gets invested at the end of every month. So we have our N is 40, and we have our I is going to be 2%, which is 0.02, okay? So 1 plus the interest rate is going to be 1.02 to the power of 40 all over 0.02, and you put it in, and there is your answer. So it's 10 marks. So, like, okay, if you strip away all the complex language, you can see there a skill which is merely substitution into a formula that we've already gotten for 10 marks. Owen, not the guy you're looking at, a different Owen, is choosing between 2 investment options: depositing a large amount of €40,000 today, earning annual percentage rate of 1.2% per annum, compounded monthly. Okay, right, so that's option 1. And option 2 is depositing €1,000 at the end of each quarter, earning an APR of 4.2% per annum, compounded quarterly. Okay, so they're different things, obviously, these 2 options. Option 1 is you're just putting €40,000 in today. There's an annual percentage rate of 1.2% and it's compounded monthly. Okay, And what is the, okay, so what's the value of Owen's investment after 10 years using option one correct to the nearest cent? So in this case, I actually think if I'm right here, that actually is incorrect. That should say compounded annually. Compounded annually. So what do? We put in our 40,000 euros and it is compounded annually. So there's 10 years and it is 1.02 is my interest, like my one plus I. So that amounts to 45,067 euros and 67 cent. And so that's correct to the nearest cent. Okay, so another 10 marks for that. And again, if you understand it, it's merely subbing into a compound interest formula. And of course, it did say annually in the exam paper. Okay, show that the quarterly rate of interest that's equivalent to an APR of 2.4% is 0.06 as a decimal, correct to 3 decimal places. Now, this is what my guys know I call key skill 1. It comes up all the time. Even so, if you hadn't got everything else right so far, this is a kind of individual question. You know, you could just do this and you're going to get your marks for this part by itself anyway. So what we're saying is like the future value is equal to the present value times 1 plus the interest rate to the power of t. So the way I explain it is I say, okay, APR is going to be 2.4. So €1 invested today would be equal to, or will amount to 1.024 euros after, well, it's quarterly, right? So at a certain interest rate, I, right? So after 4 compounding periods at a certain interest rate, I. So let me try it again. €1 invested today would become worth €1 0.024 after 4 compounding periods at a certain interest rate I. Our job is to find I. So that'll simplify down to the 1 here will disappear. 1 plus I to the power of 4 is equal to 1.024. Take the 4th root of 1.024 and then subtract 1 away. So we get I is equal to 1.006. Well, it's going to be that, but 1.005940. Not doing a very good job of saying that number, am I? Let me try it again. 1.0059467444. Take 1 and correct to 3 decimal places. As a decimal, it is 0.006. And again, there's 10 marks for that, right? 20% of this question. And that's a skill that you must have practiced hundreds of times if you're ready for financial maths, because it comes up all the time. What is the difference between the future values after 10 years of option 1 and option 2? Okay, so here we go, right? That's option 1, we know is this. It's going to come to 45,067 euros and 67 cents. Okay, so in the next option, right, we have our monthly interest rate of 0.06. This is where now we're going to have to go back to our table, right? Because here is our value associated with, okay, here's our, no, it's this one over here, isn't it? 0.006, right? And we're going to say, well, how many compounding periods are we going to have? So we have our interest rate here, and we have 40 compounding periods. Why? Well, we have 40 compounding periods because it is 10 years and it is 4 quarters per year. So it is 40 quarters. So then we're going to say, okay, €1 in kind of in the bank for the 40, €1 saved at the end of every month for 40 months would amount to €45 when you're adding on the interest rate. So in this case, it's instead of 1, it's €1,000. So you're multiplying that by the 45.05630. That'll give you 45,056 euros and 30 cent. So the difference between that, which is option B, and this, which is option A, is actually just 11 euros and 37 cent. So they're very similar either way. So that's the end of that question. And again, as we saw, the actual mathematics in it were not too difficult. But what was difficult was getting through all that dense language. If you practice enough of these questions, you'll just gain that familiarity with all the terminology. And in the end, you won't get thrown by it in the exam. So I hope you've learned a little bit by doing this question and now watching this video on it. Okay, let's move on to question 9.